Okay, we are going to draw figure 3.8. It says shows a lobster back bend with a branch pipe of unequal diameters. So if they're talking about unequal diameters, actually there is a method that we are going to use which is different when we have equal diameters. Remember, we are dealing with a lobster and a branch pipe. Okay, now they ask us to draw the given elevation and to construct the line of penetration, and lastly we are going to develop the segment marked L. Now firstly, let's draw the lobster. The radius is 250, the main radius, and to scale is 1 to 5, so it's 25. It's 50. 250 divided by 5, which is 50. So we have to set up the compass to 50. Okay, the compass is set up to 50. Now let's draw the lobster. Take the diameter. The radius is 50. Now the diameter of the lobster is 205. To scale is 41 divided by 2 is 20.5. Now we take 21 millimeters of the radius. That will be the radius of the lobster. 21. So I'll also draw in the meantime the circle which we are going to subdivide at the end of the lobster here. I'm going to subdivide it. So for me to subdivide, I'll start here. Same here. this side. Let me first wait for this side to subdivide because there is something else which I'll add up there. Okay, now let's draw the joint of the segment. This is 45 degrees. Then I need 30 degrees. I need 30 degrees and 15. So you see it's 45 degrees. I want to put it in a good way so that you can see it properly. Yeah, see 0, 45. Now 30 degrees is there. So from here to here is 30. Now let's go to the other side. The same from here up to here is 45. You see 45. Oh shame. Need to take 30. Yeah, need to take 30 to here. Okay. Okay. So these are the joints for our lobster. So we start with the first segment. This is the first segment. Then we have the horizontal one. Now we'll take the compass so that I'll see the position of the other. I'll take this dimension from here. Here. Can mark off here. Secondly, go up to there. Okay, this is the lobster. 1, 2, 3, 4 component. Now let's draw the branch. So the branch actually will be, so the center line of the lobster concept is aligned with the center of the lobster. Okay. From there, the height, they just say that if you can limit our lobster here, yeah, this is the end of our lobster. Now the diameter of the lobster is 175 to scale, divided by 5 is 35, and 35 divided by 2 is 17.5, so we'll take 18 millimeters. Millimeters. So I'll draw also the half circle, the semicircle, and let me divide it. Okay. So this is now our branch on top of the lobster. The meat here, and also the intersection is there. All right. Now, because we have unequal diameters, this is smaller than that one, so I have to take the diameter and to draw a quarter circle here, so that I'll project this line to this circle here. That is the method we are using when we have unequal diameters. We still have the same diameter. Now I'll subdivide this quarter circle. Okay. You can see that these lines now I have to draw them vertically to bring them to this Okay, so let's now write the numbers. Here let's say this is 1, 2, we have a 3, we have a 3, 4, 5, 6, 7. Now here we have our A is here, B, C, D. So here we have A, B, C, and D. Okay. Now we want to find out the line of penetration here. For us to get the line of penetration, what we're going to do is to draw parallel lines to A, B, C, D with the lines of the segment up down here. Then we'll bring the projection of this 1, 2, 3, 4, 5, 6, 7. When they will meet, then we have our line of interpenetration. So I'll start with the letters. I'm going segment after segment. Just project them auto circle here once. Okay. So see that I'll project this A, B, C, D. Project them first on the circle here at the circumference, then all the way to the other circumference. So let's write here. Here we have B, we have C, and we have our D. This almost coincide with, yeah. Okay. All right. Now let's number this one here. This is 1, then we have 2, we have 3, we have 4, we have 5, we have 6, we have 7. So here's A that coincides with 5, then we have B, we have C, and we have D almost coincide with 5. Okay. So now I'm going to project this 1 2 3 4 5 6, project them down, and when they meet these projections, so we have the line of penetration. Now the first one, they coincide here. That is the first point of penetration. The second one, they meet here. Now we have, you see, we have the joint line. So 4 actually cannot be with the joint line. 4 must be with D. So we have here. Then we carry on. No, 4 must be here. 4 with D. Yeah, not D. Must be here. Then we have here. Okay. Then we have 6 here. We have 5 here. We have 4 here. Not there. Now you see that here the 3, this is 3 from 3, this is from 4. You see that the joint is between 3 and 4. Now I have to take between C and D a point here which I'll call X, so that I'll join 3 to X, then come down here. So we have our X here on the joint. This is our X on the joint. Then I have to take all the measurement to know the distance between X and D here. I'll go again with the parallel lines. Yeah, but right now, yes, right now I need yes, X, yes. I have to get that X there so that I know how to join the parallel lines. Okay. Yeah. We have to go again with the parallel lines. You're just looking for the position of the X, which is on the joint between these two segments. So this is X, which is between C and D. Now six and yeah. So I just may remove this because it's disturbing. This is disturbing. It's disturbing. Now let's draw the curve. So this is the line of penetration. For this segment up to the center, the joint. Then this is for the other one. Okay, let first me work out. Okay, let me work out these three and these four. Okay, this is our penetration, line of penetration. Now we need to draw the development of point segment L. So this is our segment L. So before we do that, we have to draw parallel, we have to bisect it so that we get the center. How do I bisect? Okay, firstly, so it's at this point we call it M, this point here we call it N, this point here we call it T, and this point here we call it S. So our segment that we are going to develop is M and T S. So from N and T, I'm going to bisect to get the center. So this is our center. Now I need to draw parallel line from N and parallel line from T. First parallel line. The second parallel line. Now, the development, I'm going to start by the center. I need to take parallel. Okay. So this is our center. I call it number 7. Now what I'm going to do is to take, now I'm using the dimensions on this circle to subdivide the area of my development. I'm not doing that method of we draw a line and then we subdivide the line because of the position of A, B, C, and D. Just take this 3, 4, 6, 5, 4, 3, 2, 1. Six, 5, 4, 3, 2, 1. Now from there, I'll draw perpendicular line like usual. Okay. So now I have to see we have 1, 2, 3, 4, 5, 6 on this diameter, on this semicircle. Now I have to project all the projectile lines inside here parallel like usual. Start with here, F2 here. F3, F5 almost coinciding, F6 here. F6 there. Then supposed to go up today. Now I'll draw them in this segment. See, just the projection lines. Start with 6. Then we go to 5. Yeah, 5 almost coincide. Okay. Then we go 4. Then we go to 3. Then we go to 2. So see that we have 1, 2, 3, 4, 5, 6, 7. Now, as I'm about to develop MNTS, you see that on this segment, on this segment end ST, I can just project all the lines this side and I can match with the numbers, then I'll have my shape, because the cut is on top here, not at the bottom. So let me start with the bottom. It will be fast for me. Start with 1. Just, yeah. And 6. Okay. Then again, we have 7 and 7. 7 and 7, 6 and 6, 5 and 5, 4 and 4, 3 and 3, 2 and 2, then you have 1 and 1. Now I can draw the curve. I just want to go with 3, 3, 3 dot, 3 dot. It's 3. This one. Yeah. It's missing. Take the long one. Okay, so this is the bottom part. Now let's see if the top is MN. Now with MN, you see that 1 is here, 2 is there, 3 is there, 4 is there, 5 is there. So after 5, that way we have the cut. So 1, 2, 3, 4, and 5, I can mark them by matching them. It's only from 5 to 7, then I will use the curve, you see, because then I'll go with A, B, C, D, and X. So parallel. You start with 5, then you have 4, F3, F2, 2 and 1. Almost coincide. Okay, there we go. Start 1 with 1, 2 with 2, 3 with 3, 4 with 4, and you have 5 there. And here we have 1 with 1, 2, 2, 3, 4, we have 5 here, we have 5 there. Okay, now I need X. So X is this one. Now before that, I have to show here, you see, between 7, 6, and 5, that way we have the letters. Yeah, so I need also to have them here. Leave first compass. Now we see we can take from A to B. This is A to B. So we have A is with coincide with 7, then you have B here, then C, B to C, B to C, B to C, this is C, this is C, now C to D, they're almost coincide with 5 with my drawing here. D, my D is almost with my 5, not really. It's half millimeter. Yeah. Millimeter. So FD here, FD here. Okay. Let's now bring X. It now bring X. So that it will help us to get the highest point. All right, bring X here. Then X will go there. Then no, I don't need here. I only need X on top here. Okay, let me project it there. X is here. Project it. This is the line of X. That will be the highest point of our curve. Okay. This is our X. Yeah, that is the highest. Okay. Then I need now to bring X here. X, you can take it here. This, oh, yeah. It's half millimeter. Yeah. So X is between D and C. Between D and C, I have here X here. Between D and C, I have my X here. Okay, on the vertical lines. So my X is here. And this side, my X is here. So this is the highest point. Now I have to take D, CB parallel. After that, I'll take again from here A, B, C, D. That first the vertical ones, start at the center here. So this is B. This is the line of C. And that is D. F and B. F, C. D. Now here I have A, B, C, D. Okay, so I don't mind them. Now what I'll mind is here, because what I have to draw actually is, you see, we have X, all right, we have this one here, which is 4, then we have here, we have here, we have, so I need 1, 2, 3, 4, 5. So the fifth I have already. Now I need this one here, yeah, because I'm dealing with the line of penetration. I have only 1, 2, 3, 4. The fifth is already there. Now I need this position of this one. This is D. You see, it come up to here is D. So I have to take D here when they'll meet with the other D. Axis. Yeah. This is D. Meet with D here. Meet with D here. And here. And here. So yeah, there is something of inaccuracy here, but this side D is far from, yeah. So D and D. Now I'll go with B and B and B. B and B. Oh no, this is C. This is C. C is here. C is again here. Then I'll go with B. This is B. B is here. And B is here. So there is only D here, which is a bit, oh no, D is here, this is X, yeah, D is there. Okay, I did not try it, let me do it. So that D is not really accurate, I'm mistaken there. Take the D. I did not draw it, that was the line of X actually. So D is here. This is D. This was X. This is X, so D is here. So that means D goes, so D is here. I need to erase the other one because it's on the X, not on the D. Okay, yeah, perfect. All right, so I have all the end there. I start with the numbers, then I'll end up with the letters. Yeah, let's go with these 3. It doesn't work out. Almost. Okay. On this side. should go here. One remaining. I didn't work out this one. This must go F7. I didn't work it out. The lowest point actually. This is the lowest point. F7. Yeah. Hi. So too much lines. You must get used to this. You have to work to get used to all the lines, interpretation of the lines. Let's see with these three. Yeah, not really. To see if I can get it once. If not, so okay. Just me take 3, 3, 3. Just me go 3, 3, 3. Start with this 3. Okay. Wow. Finally. So this is the end. Okay. So this is the development of our segment L. So thank you so much. Bye.